All right, welcome to Vegas Programmers. Thanks for everybody that came through today. Happy New Year. We have an amazing talk tonight. Before we get started, I do want to just shout out Corporate Coworking. There's a couple of QR codes here on the wall. I just want, blah, blah, blah. Corporate Coworking is a modern co-working space designed for entrepreneurs, freelancers, and growing your teams who just want more than just a desk. In fact, I came here last month with some clients, and we grabbed this boardroom here, and then we swapped over to this little pod. Great meeting spaces, not noisy, things like that. It was an awesome, everything went flawless. So it's a professional workspace with a strong community. All the people that work here are great. Tony's awesome. The other people I've linked up with when I've been working here. They have flexible memberships. They have meeting rooms, like I mentioned, and all that great stuff. As a thank you for being here tonight, every attendee here gets a free day pass. So if you want to try out the space, or you just want to get away from the kids, the dog, a spouse, whatever, you have that for free. So you can go and sign up by just scanning one of these QR codes here, or connect with me at the end of the event, and we'll get you all squared away. So definitely take advantage of it. And tonight we have Chad Columbus. A little round of applause, everybody. Come on, let's feel the energy. Thank you, thank you, thank you. I love the title of this, by the way.
Title?
Yeah, there is no cloud. It's just somebody else's computer.
No, title.
I'm a dinosaur. There is a yeah, he's even got the shirt. That's awesome. So I'll reread the thing here. So learn about hardware and software of computer clustering. IT is a team sport in every way. Hardware like CPU, GPU, RAM, and storage have to work together with the people that create and maintain software and websites. Just like sports, everyone in tech is rooting for their home team, be an OS, programming language, or cloud provider. In today's world, that includes a lot of you using cloud computing, containers, VMs, serverless applications. But do you know how these providers provide those services? By the way, when I was at a previous company, there was a server underneath one of the architect's desk, and we were trying to search forever for where the heck this IP was, and we traced it to literally like a Dell machine underneath his. He was like, oh yeah, that script lives right here. I was like, great. The cloud is nothing but a cluster of computers offered by a provider, yada, yada, yada. We'll talk about Chad here a little bit. Chad here is a software developer and system administrator with over 30 years of experience. Yeah. Hey, as long as you're keeping up, right? This is an interactive session, so is it cool if people like
shout out, interrupt, don't worry, all that's great.
Cool. And this is a conversation, not a lecture. And I'm sure we have various degrees of experience with cloud computing, things like that. So again, if there's no, levels of like, oh, it has to be this sort of question. If it's literally just you're confused about something, raise your hand. That's the only way you're going to learn.
Oh, wait, I'm not supposed to be.
I don't have the answers for you, sorry. So anyway, think of this as a dodgeball game and come at him with your best questions. Did anybody bring the dodgeballs?
Anyone? No one?
Okay, all right.
Metaphorical, I guess.
Yeah, we do have pizza. I should have brought tomatoes instead. Anyway, so thank you everybody that came out. I do have I have a couple of badges. In fact, I'm going to have an even funner badge to give away later on this year. But this was a really cool one when I was out in Portland. So if you're into like security and stuff, I know some people kind of collect these. I'm giving this away at the end of the meetup. The way to win it is Chad's going to ask a question regarding his slides. Whoever gets it first wins, all right? And we also have, I think, 2 or 3 JetBrains licenses to give away as well. So if anybody needs a JetBrains license, we'll figure that out here at the end. And I have a couple more words here at the end. But yeah, okay, cool. Then I guess without further ado, you're already clipped up.
Yep.
Let's rock and roll.
Give it up for our founding member and organizer and his co-organizer. So my name is Chad Columbus. I am your socially awkward presenter. So if you ask questions, it won't be rude to me because I won't even notice them. Feel free to shout out, raise your hand if you feel like being more polite. But it always makes it better when people ask questions. There's no such thing as a stupid question. If you don't know CPU stands for, or GPU, or some other acronym, shout it out. We'll get it straightened out for you. Someone in the room might know. I probably won't, but don't worry. As Josh mentioned, I have over 30 years of experience. I'm a dinosaur. I started with Sun operating system, System 5 Release 4. Linux wasn't even really a thing in the corporate world yet. That didn't last too long. Before that, for school and for my first job, I was a PC tech. So repairing computers, which probably isn't a thing anymore either, unfortunately. And then I moved into software and system administration. Does anyone know the Netscape web server? That was 25 years ago. So I did work on those kinds of things. So IT is a team sport. I consider it to be one of the most important things that people can sort of learn in this industry. We work together with the business people. We work together with user experience. We work together with graphic designers, finance. We got to deal with our budget. If you think that you're operating in a silo, even if you're a one-person show, you just aren't. You're asking your friends, you're asking your family, you're coming to meetups and asking random strangers questions. You're learning about things from an attorney you might consult or a CPA. So it's just really, really important that everyone understands that working together, both from a human perspective and in the computer world, is absolutely critical. And clustering is all about teamwork. So a very, very brief, what is clustering and virtualization, which are two opposite technologies that do work together well. So clustering, for the most basic, is two or more pieces of hardware working together to act as a single piece of hardware. Virtualization is the opposite. It's one piece of hardware acting like more than one piece of hardware. So when you think of the cloud, you think of a virtual private server or something along those lines. You just have tons of hardware that's just presenting itself in many, many more virtual machines. There's two types of hardware clusters primarily that we're going to talk about. High availability and high performance. Anyone here heard of the top 500 fastest computers in the world, the supercomputers? Anyone? So those are all high performance. They take lots and lots of computers and they chain them together and they work on a single problem. Those machines, out of our price range, right? None of us can really afford to be in the supercomputer world. But high availability is one or more computers acting together so that if there's a failure, you don't notice it. So this can be as simple as an automated failover. So you have two machines, you have a primary and a backup. If it automatically switches to the backup and none of your customers know, that's a cluster. How clusters and virtualization work together is primarily for failover and redundancy. So has anyone here heard of or used Proxmox, which is a hypervisor? So Proxmox will let you link your hardware together. And if you share everything properly, if your VM is running on the first machine and it has a problem, it will automatically migrate live to the second machine and continue running. In addition, virtualization is a great way to do your staging and development stacks, right? So you might have like 40 servers in your hardware cluster. You don't want to try and buy 40 more servers for your other stacks, right? You don't even want to buy 10 or 20. So if you virtualize maybe one or two machines, you can emulate your live stack in those staging and testing and development environments. So a very, very brief history of clusters over time, and I do mean brief. When I started, we called it grid computing, and then it became clustering, and now we call it cloud computing. There was sort of a project, which if you're old enough, you might have heard of. It was SETI at Home. Does anyone remember SETI at Home? It was like a little program you could install. It was like a screensaver. And when it was running, SETI would send you data from the telescopes, and it would process that data because it didn't have enough supercomputing power. So it essentially just split that problem up over all these home users who installed it. It was technically the first botnet. Right? It was voluntary, right? It wasn't a bad guys taking over your machines, but you installed this little program, and when your machine was idle, it would dedicate its computing. So that's clustering. Denial of service attacks are also clustering, just the bad guys doing it. We don't like those. Over time, computers have changed. This is a 10-year snapshot from 2010 to 2020. The blue lines represent people purchasing hardware and using that on-premise, and the gold lines represent people using cloud services. And I think there's a couple of reasons why that's happening. I think the primary reason is if you're a small company, you don't have all the resources. You don't necessarily have the money to buy a cluster. You don't necessarily have a system administrator with the experience. Even if you hire one, you don't know if they're any good. So you might be nervous if you're a small business to try and manage it yourself. You have security concerns and hardware concerns, configurations. And if you go to the cloud, they make it a lot easier for you. I think in addition, you have to worry about hardware failures and how that's going to work, power, network. In addition, at some point, your hardware is going to get old. You're going to want to upgrade it. So what's your path to doing that? And so cloud makes more and more sense. Now, it doesn't always make sense, but over time, we can see that, especially for smaller businesses or businesses that are seasonal, right? If you do all your business in the fourth quarter because you're a holiday business, you don't need all that hardware sitting in your rack, using up power, using up resources, and being administrated 3/4 of the year. So you can go into a cloud provider, scale that down, get into the fourth quarter, turn everything up, and there's a lot of convenience to using a cloud provider's cluster. And it's a great way to do that. I think that there's also a way to do it on-premise. Now, I have a very strong example. So I had a customer that was doing a database server in the cloud. It was costing them about $5,000 a month. We bought a server that cost them about $35,000, one-time capital expenditure. That machine was 5 times faster than the cloud provider's machine. It paid for itself in under a year, even if you include the power, rack, and network for their hosting. So that doesn't include the fact that their developer was getting work done 5 times faster. Instead of something taking 24 hours to process, it was processing in 4 or 5 hours. And she was able to run 2 jobs a day instead of 1 job every 24 hours. So you have to keep in mind there are use cases where your on-premise solution, if you can afford it, is much more powerful. So this is what I consider basically the smallest cluster. That would be 7 machines. But I want to talk about why clustering makes sense. And this is insects versus mammals. So mammals have a small number of children, right? Usually less than 10, maybe a dozen-ish, right? So humans, we usually have 1 at a time, maybe 2 at a time. If you're dogs and cats, you might have a dozen. But mammals are parents. They take very, very good care of their offspring, and they feed it, and they educate it, and they grow it, and then they send it out into the world. Insects, on the other hand, lay 100,000 eggs and leave. And they don't care who lives and who dies. They just let it be. Google started this with containers of servers. And when one died, they literally would just turn it off. They didn't diagnose it. They didn't try and fix the hardware. They didn't even go look at it. They just remotely disabled it and kept going. And just had hundreds of thousands of these machines in a container, a shipping container, and they just had them all over the country. If something went bad, they just turned it off and didn't care. Insects. So we like insects for clusters, right? It makes things easy. 2 in the morning, if a server dies and it's a mammal, you're driving, right? You are going down there, you are fixing that thing. If it's an insect, you just don't care. So the key is insects versus mammals. If you're going to do a cluster, you want to do insects. I was working at a company, and this is how I ended up getting into clusters. We had a system administrator, and I was the lead system developer, software developer, and we worked together to set up a cluster. We've been talking about it for months and months, but we couldn't pull the trigger because every 6 months or a year, we'd sort of getting near our capacity. We had a primary machine with a backup, and when we got really close to its capacity, we just buy a faster machine. And we just kept going. It doesn't make sense to spend all this capital to buy 3 or 4 servers for the compute level and 2 load balancers and a bunch of extra switches. It just doesn't make sense. Well, one day, we needed to get a new server. We're getting near capacity, and Intel hadn't made a faster CPU. So guess what? We didn't have any choice. We had to go to a cluster. So that's how we started in this. And so the way that this breaks down is we're going to start at the top here, which is the load balancers. We always try and do 2 or more of everything. We try not to have any single point of failure. So that means not only do we have 2 load balancers, but each load balancer has 2 network cards for every network it's connected to. In this case, it's connected to the internet and our yellow network. So it's going to have 2 network cards in it that are dual cards. So a red goes here, yellow goes here. Second red goes here, second yellow goes here. Same on the other side for the other switch. So you have each load balancer connected to each switch, and you have each load balancer have 2 connections out to the internet. So you'll have a pair of switches up here. Your internet connection should be redundant from your service provider. Can't always do that, can't always control it, but normally if you're in a data center, that's not a problem. So what we have here is our red network, which is connected to the internet. So we consider that could be completely unsafe, it's completely unfiltered, highest level of security. We don't trust any information or packets coming from there. Then we have our yellow network. This is the traffic that's happening in between our compute nodes. In this case, this is a web cluster, so these are HTTP web servers. That traffic is happening between the load balancer and the switches, and the web servers. That is yellow. We've filtered some of it. We don't let through just anything, right? We don't let through, let's say, NTP traffic or DNS traffic. We only let through HTTP traffic, maybe SSH traffic. So we're going to limit that at the load balancer, and so that traffic is slightly safer, which is why it's the yellow network. Then we have another set of switches and another network, which is our green network. This is an entirely internal network. It only operates between our internal machines and, in this case, a database cluster. We're also going to talk about storage, distributed storage. Usually I use the web server nodes for that, so I don't have to have another set of machines. There are cases where you want another set of machines, and we'll talk about that. This traffic is all completely internal. Now, we should never trust anything 100%, but this is as close as we can get to the trusted network traffic, so that's our green network. So we start at the load balancers, work our way through our web servers, and then this is our back-end storage. In this case, it could be database, it could be distributed file system. Next, we have our computing and web application layer, and depending on how your setup is, this could be web servers and app servers, this could be all-in-one machines. This just depends on what your needs are. We always want to have at least 3 machines. We're going to talk about split brain. So in the case of syncing the data between them, there's a couple of different ways. The cheapest way and the simplest way is something like rsync. So if you just have a plain old HTML file or an image, if you have enough room to store them on these machines, there's nothing faster than just copying those files to those machines from your dev environment and just serving them up directly without using the distributed storage. It's just faster, right? The hard drives directly connected are always going to be your fastest connection. So the key there is if you do that, though, and one of these machines goes down, when it comes back up, it's out of sync. So you have what's called split brain. This guy has the latest file. This guy has a file that's 4 hours old because you pushed something new while this one was offline. So you got to be careful about that. You want to make sure if you live in an environment where you have a single machine that has data directly on it, it has some kind of routine that syncs itself before it puts itself back into service. So that way you don't get split brain where you have different data on your machines. You always want the same content to be delivered. Questions? Come on. Someone? Anyone?
So you're talking about the way that it used to be done, like 10 to 15 years ago.
This is how your cloud provider does it today. Amazon does this, literally.
So if we're in AWS land right now, which services are handling load balancing,
So they have load balance services specifically that you can sign up for. Have you ever done that where you have multiple nodes and they'll cluster them for you? Yeah. Okay, so that's happening there. Yeah. Okay. These guys are your compute, your EC nodes, right? These guys are going to be your storage, whatever your storage happens to be. I just represent it as a database cluster, but it could be hard drive, right? It could just be, SDA. So this is literally the same representation. It's not the same technology, but it's the same representation as to what AWS is doing today.
I don't really use I don't really use cloud, right?
Okay.
But you're telling me that if you guys use rsync to have storage on the nodes, right?
Mm-hmm.
So my understanding is that when I go to AWS, I just get either a random IP that I get access to. How do I know that the same IP I'm using for storage for my nodes is connected to the same node that I'm hosting my site on?
Right. So
Or does that not matter?
So in AWS, it's different, right? Because you will link the storage by its ID. You won't do it by IP address. So they'll give you an identifier. You'll link the storage by that identifier, and they'll manage the IP in the background silently. So you don't see that representation. They've extracted it to another layer for you. But the same thing is happening. Their storage, we'll talk about distributed storage in a minute, but that's all they're doing is they're taking your files and they're moving them off. You don't have a physical machine, so your data is not sitting physically there. It's sitting in a virtualized hard drive. And that hard drive could be moved constantly. So if they have a hardware failure, that drive might move to another server without you ever even knowing it. It's all just linked by its ID. Sure?
So I'm guessing, like, I'm wondering which parts are actual technology, like physical hardware, and which parts aren't. Like, so the load balancer, is that?
Two physical machines, physical hardware, right? And then they are linked together by a single IP address, which is what's called a virtual IP. So it sits on one of them. If that hardware fails, there's a heartbeat between them. And the second one goes, hey, that guy went away, and it takes over the IP and tells the internet, I now have that IP. So your traffic goes from one to the other one completely seamlessly to the rest of the world, and your traffic continues flowing. These are all physical machines, right? So we have web servers, however many you might have. This is a database cluster that usually means 3 or more servers acting as a database. I like to put my distributed storage on my web servers so that I don't have to have separate machines. But you could have another one of these right here that represents your hard drive. So let's talk about distributed storage. So there's a couple technologies out there, maybe 10 or 15, and there's probably 8 of them that are sort of viable, production ready. One of them is Gluster. I wrote them down here, my short list. Ceph, anyone heard of Ceph? Hadoop, which is a little bit older, and it's also an object model versus hard drive based, which we call block device. And then there's BGFS, which is really good at a bunch of small files if you ever need a bunch of small files. So what's happening with those technologies is, let's say you have 6 bays, hard drive bays in each of these servers, and you're using 2 of them for the operating system in a mirrored pair physically, and you have 4 open bays in each one of these. You can take those 4 hard drives in each of these, the 16 drives, glue them together as if they're together in one RAID array with redundancy, and now that data is striped across all your machines. Now you get less storage. So let's say that was 1 terabyte on each of these. You might only have 1.5 terabytes total instead of 3 terabytes available because it's using the rest of the space to clone the data, right, between the different machines. So now if this machine goes away, these 2 machines have the identical data because it's part of that distributed cluster. When this comes back up, it also has the same data because it knows it's out of date, and it'll use these 2 until it's synced itself. And then once it's back in sync, it'll start using its local data. Does that make sense?
So I haven't really used, this is cool by the way, I haven't really used AWS, so am I sending my servers there and also like with the hard drives in them, or AWS is letting me know, hey, your web servers have this many drive bays?
AWS is providing the hardware. You don't send them anything. You just upload your data to them. So they're providing 100% of the physical stack. They're providing you a virtual machine. You upload your files, your web server files. You spin up a web server on it. If you pick it, you can have a full machine with root access. So you can log in, install Apache or Nginx or whatever you're using for your web server. You can install databases. You can install whatever you want. They also have a bunch of services they provide, like database services. So instead of having to spin up your own MySQL, you can use their database, and then you just link it to your machine, and they give you essentially an IP address.
So I could just pick like how much storage I want on each.
Yeah, so the big downside, in my opinion, of the cloud is the cost, right? So we talked about spending $5,000 a month and getting a machine that's 5 times faster for $35,000 at one time. So if you just think about, if you spin up an AWS specifically instance, they usually run you $200 to $400 a month. You can spin up a virtual private server in some places for $10 a month. So you don't have to spend that kind of money. But if you're going to spend $400 for a single instance, you can host that somewhere for probably the same money and pick whatever hardware you want. So depends on your needs. There certainly are advantages in that they do all the system administration. They handle all the hardware failures. You don't have to have any of the system administration. They do all that for you.
So here's a question. Today I read a LinkedIn post about a rapidly growing startup that ran into this issue where their cloud compute costs were eating to a lot of their operating founder did was they got rid of AWS. They reduced their dependence on AWS. They chained 3 M4 Pro Mac Minis together using them as local development servers, and they did most of their. I think they hosted their application layer and their data layer on these local development machines. But the part that I didn't quite understand was he said he took a hybrid approach, this founder, where they were still using like AWS SQS for receiving messages, and somehow these machines were listening to SQS. I presume they had a dead letter queue for when the local development machines aren't intercepting messages from the queue, then they need to be sent to a DLQ for processing later. But he said that he was able to greatly reduce his expenses. So he had a one-time capital expenditure of buying 3 development machines and then hosting everything locally using Docker, Kubernetes, probably SQLite. So the question is, for companies that aren't big enterprises, that have a fixed budget for development costs, for cloud infrastructure, that sort of thing, let's just pick an arbitrary number like 10,000 per year. If you wanted to design a system that replicates what you could easily do using a cloud provider like AWS, using consumer hardware like Mac Minis or Mac Studios, how would you build something like that?
So I could kick a Mac Studio's ass with real servers, right? So I can buy a server that has 4 nodes in it, that has a modern Intel CPU, a scale processor for about $2,500. I get 4 servers for that. I can get last generation's CPUs, right, for about $1,000. So I can build that server for $2,500. I have 4 nodes. So let's say I buy 2 of them. I have the 7 servers I need that I consider the minimum for a cluster. 3 of these, 2 of these, 2 of these, right? So that's how I get my 7 servers. And now I'm in for $5,000. Now the other $5,000 I can need to spend on hosting, right? I need a place to store them with power and network. So I can find a local place that'll give me a half rack for probably $500 a month. And now I have a 1 gig connection with power for my 7 servers. I set this up and my cost is $500 a month the end. You can get 1 AWS server, 1 for that same $500 a month. So yeah, you had a $5,000 capital expense to get that build out done, but once it's there, your $500 a month, as long as those servers are good, never goes up, right? No matter how much traffic you get, as long as they're enough to handle the load, the price never goes up. So there's advantages to doing that. Now, if you're a small business that's starting out and maybe you have a $500 budget, you can't do it. You need to get some kind of cloud server, right? Get you off the ground, get some traffic, get some revenue. Then maybe you grow your cloud. Maybe it doesn't make sense for you to go local. You also have to have the skills. If you don't know how to set this up yourself, it's going to cost you more than $10,000 probably for a system administrator to do it for you. So there's a balance there between the budget on the ongoing cost side and the one-time expenditure to set it up. My guess is what these guys were doing is they're using AWS as their public-facing side, and all the traffic that comes in, they then pass it back to their 3 machines locally, just over IP. If that connection is severed, they've configured their AWS to just queue up those messages and send them an alert, hey, I can't reach the local stack. Somebody goes and deals with the local stack and gets it back up and running, and then they send those messages down to it. Yes?
I just want to call out, I think you're also kind of trying to tackle scaling strategies with that, right? Like, you brought up founders, you brought up scaling startups. I imagine they have a baseline of cost there. So for them, it's economically feasible to hire somebody to manage all that infrastructure. If you're like a true like grassroots startup, you have no money, you have nothing. You're better off going with almost a serverless infrastructure until you get people paying you, because then you're paying based on usage, not based on machine space. If I've got 4 racks sitting there, but I've got no one using them, that's just dead space.
Yep, absolutely.
I can host some Lambdas, I can host something on some application platforms with like Railway or something cheap, and then as I get customers, I can look at optimizing costs later.
Yeah, so I mean, basically, he's giving you the exact reason why cloud is powerful. You can start off at really low, really small, scale that as you grow, and decide when it makes sense to do the capital expenditure. If you are a startup with $1 million and you can afford to build the stack and it makes sense for you long term, you can go straight to the hardware cluster and save yourself the monthly fees. So again, it's a balance between, honestly, financing, right? Is it better to have it as a capital expenditure or better to have it as a monthly operating cost? Did I have one more? Sure. So basically just think of these as computers, right? Just like your laptop would be or anything else. You would log into it and you would manage it. You might have, and we haven't talked about that, but there are management systems like Ansible, Spacewalk, which I don't think exists anymore, Foreman, Puppet, and Chef. And so those are systems that basically you can tie all these things into and have config files, and they automatically read that, and whatever you change the configs, they get copied out to all the machines. So what I haven't represented here is any kind of a dev environment or staging. This is just the production. But normally you'd have a smaller system, might be even one machine, that's sort of your command and control, where you would log in, you'd see what's happening on all these machines. You might even have a web dashboard, like Proxmox has a web interface that'll show you what your machines are, what their state is, how busy they are, what storage they're connected to. So it depends on how you're managing this. You could manage this at the operating system level. You could log into these machines through SSH and manage each one individually. I don't recommend that. The largest cluster I worked on was 100 machines. Can you imagine logging into 100 machines to issue one command? It's just not really viable to do that. You need a management system. That stack, which had 100 servers in it, we did anywhere from 120 million to 150 million hits an hour. I think our biggest day ever was 1.5 billion hits. So you can scale this really big. You know, don't think like, well, how can AWS do it? It's the same. It honestly is the same. The same exact structure. Just think of more of them, just insects, just more and more and more. That's all we're talking about doing. So the database is a little different. It's a mini cluster like this. So normally, depending on what database you're using, you will have a load balancer sitting here, and your nodes talk to that load balancer, and that load balancer is sending the traffic to your database servers. And that way, if one of your database servers goes down, these guys don't even know it. The load balancer just sends the traffic to the other ones. So you can build a pair of load balancers here, and then you build your cluster of database servers behind it. So that same philosophy of how does this work, we just repeat it down here and use that same technology down here. Same exact thing. Now, the key with database servers is, depending on what you're running, but we'll just take MySQL as an example. One of the downsides of MySQL is sometimes if a node goes down, when it comes back up and it knows that it's out of sync, it talks to one of the other servers and says, hey, I want to be in sync. Sometimes if you are near capacity, that donor server can only service the server that's coming back up. And now they're both out of service while they're syncing. So if you have 3 servers in this cluster, and 2 of them are offline because one of them is syncing and the other one's the donor, you're down to 1 server. So we try not to get into that environment. If you build something like that, you try and build 5 servers or 4 servers so that if you have 2 machines that are out of service, then you don't have that single machine point of failure. If they're big enough, then the donor won't be out of service. It'll be able to service incoming requests as well as being a donor. Any questions about how that technology works?
Okay, so focusing just on DB clusters.
Sure.
So you're talking about reliability, availability, redundancy, right?
Mm-hmm.
If you have a 3-server database cluster, one of them goes down and the other is a donor server, then that's a problematic situation
It is.
for a DevOps person. That's your job on the line. So is there a rule of thumb for the number of servers that you should have relative to your...
So n plus 1 is sort of the minimum we would do, right? A primary and a backup. That's n plus 1. N is the number of servers you need to service your traffic plus 1 backup. Almost all data centers will be n plus 2. So they'll have redundant power. They won't just have 1 backup, they'll have 2 backups. So if you have 1 power coming into your rack, they'll have at least 2 other circuits that they can send to you that are on a different generator, different battery backup, etc. In the case of high-end ones, like Switch, if you've ever heard of Switch, they have 4 total. So if you have 2 circuits, you can have 4 independent power circuits in that rack. If one of them goes down, its failover, let's say it's on A, its failover is B, then you also might have a C rail and a D as its backup. So you might have 4 completely independents in that case. So that's n plus 2. Now in the case of database servers, because you know that 2 of them could go down, you usually want to be at like n plus 3 so that you have 5 of them. So if 2 of them are out of service, the other 3 are operating just fine. If a 4th one goes down, you still have 2 running. But it depends on how much capacity they have, right? If these guys are at 80% and one of them goes down, you're losing the whole stack because there's just not enough bandwidth for that thing to handle. You're going to get what's called a cascade. So you have to manage how many of these you have based on the volume of traffic that you have. You want to keep those low, 50%, so that if a bunch of your servers go down, you don't get a cascade failure where the other ones just get overwhelmed with requests and they can't handle it.
Does the kind of database, are certain types of databases more liable to a sudden surge in, let's say you have a streaming service like Netflix, right? They're hosting 2 or 3 hour films, and maybe they have a Mike Tyson fight or something, where you
Yep.
have a huge surge in user traffic, all for a live streaming event. So how do they design a system to accommodate periods of sudden surges in traffic all at once and then it normalizes?
So for them specifically, right, they have the problem of they're hosting all their own stuff and they have to have enough hardware to handle whatever the maximum they could imagine is, right, no matter what it is. So that, let's say during a normal week on a Wednesday, right, they might be at 5% of their total capacity. Because when Tyson fight comes around and they have this giant spike with 20 million people that sign up for the fight, they have to have the hardware available to do that. Or they can partner with something called a content delivery network, where they stream it out to somebody who specializes in bandwidth distribution. Now they have just essentially a very small number of servers, but extremely high amount of network. So Netflix streams to them, and then they redistribute that content in real time over their network. So Netflix is unique in that way that they don't necessarily need database or hard drive or compute, they need network. If you're using something like an e-commerce shopping cart, now that changes the model, right? It's not streaming, it's database, it's customer transactions, it's credit card processing, it's loading images for products. So again, we talked about that seasonal business that has all of its traffic in November because people want it for Christmas, as an example. That's ideal for a cloud provider that can scale up your bandwidth and your needs just for that short period of time. In fact, you don't even have to turn it up yourself. You can have it on auto scale so that as your traffic increases, they just start charging you more. As your traffic decreases, let's say at night, they just charge you less. So they'll scale that for you automatically, and that's a huge benefit if you're in that situation. Now, if you're just worried about we're launching a product and we're going to get a bunch of traffic in, you can handle it in this model. The biggest key to that is try and do as much static file as you can, right? A static HTML file or graphic is going to be, let's just say, 10 times faster than a CGI program or a database call. So if they're coming to look at the new shirt that you just released, if it's a static HTML page, tens of millions of people could hit that. You wouldn't even notice. It's not enough bandwidth and traffic and compute for you to notice. So there's strategies on how to manage that if you have limited hardware resources.
Right, streaming services are going to be a more difficult thing than rendering
Yep.
static web assets.
And especially for small guys, right? Your Netflix, you have billions of dollars. You can manage it on your own. You can buy your own fiber, et cetera. If you're small, use somebody like Akamai, which is a content delivery network. That's specifically what they do. You pay them when you have traffic spikes, and they distribute your content, your video content for you.
Why did Cloudflare went down a few weeks ago, right?
Yep.
It was down half a million. Why did Cloudflare go down?
So that goes back to this question over here, which is how do we manage thousands of these nodes? We have a configuration server. Some system administrator made a typo in a file. He hit send. He sent it out to thousands of routers. They all went, doesn't work anymore. So that's why it went down. Close enough, right?
I don't know how long something is down for or something or like that. How much it matters whether they can get it back up quickly or not. But I guess all the data is synced throughout the clusters. Is there an issue when one comes up that slows down the other servers because it's been down for so long, or
So-
they have to catch up?
So it depends on which layer we're in. So when we talk about this layer where we have distributed storage, remember I said we have maybe 4 hard drives in each of these that are glued together? So this guy comes up, he's been down for 3 months, right? His data is way out of date, right? He knows his data is out of date because he checks the timestamp. And he goes, okay, my data is bad. So he uses the data from the hard drives on these machines over the network while he synchronizes his until he's back up to date, and then he uses his local copy. So that's called distributed file system. So Ceph and Gluster, those are those technologies where they will sync those when it comes back up, and it'll keep it offline until it's synced up. Yeah.
If there's an or is it something else?
So DDoS is essentially getting as many people as possible to make requests to your servers to overwhelm them. This is where you fix it. This is where you say, okay, let's block that traffic from that network. But yes, you can get overwhelmed straight through to here is really, these guys, all they're doing is routing network traffic. So there's no CPU, no RAM really happening at this level. It's just a packet comes in, it goes, okay, which of these servers do I send it to? That's the only thinking it does. Once it sends that traffic, it repeats all the following traffic from that IP straight through to that server. So you come in, you hit the load balancer, it sends you to the middle guy here. All your subsequent requests will get passed to here. And then if this server goes down, it knows that and it'll start routing you over to here. And that does bring up a good point. We don't use anything in RAM on these guys. So if you're storing your session in RAM, this guy goes down and you're suddenly on this machine, your session is gone. So that's why we want to use either the database or the distributed network so that that file system information is available to all three. So if one goes down, as an end user, you don't know that's happened.
Yeah, so database clusters probably run something like Hadoop or whatever for clustering, right?
So for the database, I ran something called Percona on top of MySQL. They have their own. They also have Galera. If you're running something like Postgres, they have built-in master. It's very nice. I believe Oracle does as well. It's too expensive for me, but.
If we go below to the node layer, for like application failover, like what software packages are the providers?
So the way that I do it essentially is I store everything about you, all your session information, in distributed storage. So I don't put anything in RAM. So on the big cluster of 100 servers, we actually had a memcache cluster separate from that. We would send all of your information into the memcache cluster. So if a node went down, your next HTTP request hit the next server, but it went to the memcache to get your session. So all your session values, your shopping cart environment, your login, all that stuff, all your tokens, all stored in distributed storage. So it doesn't matter which of these you're on. There is nothing to sync between them in that sense.
Maybe that's kind of like an old paradigm, but we used to use something called Veritas cluster, right? That had application failover. I don't know if there's equivalent to that.
So I mean, maybe that's a client-server paradigm. I mean, for us, it's a web request, so it's stateless, essentially. The request comes in, the next one that comes in can go somewhere else. Sure?
Okay, I've heard Redis before, but I know it's like it was a caching. I'm not sure if it would be involved in any of this, or if that's like a different part that would be in.
Redis, I believe, is just a alternate version of memcache. So basically what that does, for those of you who don't know, is you take a server and you convert its RAM into a hard drive, which is the fastest memory we have, right? It's the fastest access. So now when one of these guys requests that data, instead of getting it off of a hard drive, we're getting it out of memory. So that's just super fast way of doing it. And that's just a very basic principle of what those things are. Those are caching, is what we call them, databases. So it could be NoSQL, if you ever heard of that. A lot of them will use a RAM strategy that will write to the hard drive later so that they can be as fast as possible. I think it's Couch or Mongo that does that, where it stores everything in RAM, and then like every 5 minutes it dumps to the hard drive, which means if you lose the server, you lose 5 minutes of data. So it's just very important you don't store anything in there that's not mission critical, or you have 2 copies of it. So we always had a cloning, so we'd have it in 2 different servers. So if one of them went down, it would then just call the other server and get the same data. Any other questions?
Let's focus on load balancers for a second. In AWS, you have different types of load balancers. You have elastic load balancer, application load balancers, and network load balancers. So in the context of this, of a system like this, how are you using different load balancers for different purposes?
So the main difference between this and AWS is that this would be like a service level. So HTTP traffic, or let's say voice over IP traffic, or email traffic or something. You would specify a set of servers that would handle each of those services. So all 3 of these might service HTTP, but you might only have one that does email. So all of your email traffic that comes in always gets routed to one machine, and it might be on a failover instead of being in a cluster. Your voice would be the same way. You might have voice that comes in, phone registrations is happening on one set of servers, and the actual phone conversations are happening on a cluster. So you could set that up and route that however you want. They're giving you 3 different names for the same thing. They're just doing it on different services. So they're not actually, there isn't any difference in actually in how that happens and what that's doing. They're just making it easy for non-system administrators to understand this is for applications, this is for nodes, this is for services. But the reality is they're all doing the exact same thing, taking an inbound request and sending it out to something on your back end.
When you talk about scaling, and so you manage the system with like 100,000 nodes, you said?
100 nodes.
Oh, okay.
Yeah.
How?
So sort of my next slide, which we can come back to this one if we need to, maintaining clusters. So basically, the way that I deal with failures and expansion and new nodes and just configurations and everything is with a management system. So I mentioned some of those earlier. There's Spacewalk, which I think is now gone. It used to be an open source project from Red Hat. Foreman, I think, took that over. I forget, there's another one that goes with it. They're partnered. Ansible, Chef, Puppet. These are all configuration managers. So what you do in those is you would have a configuration file that's, say, for that middle layer, those nodes, and you might have different things in that layer. So you might have nodes that are web servers, and you'd have a config file for that, and you would assign MAC addresses or IPs to those. When those boot up, they call the configuration and say, hey, what's my IP? What are my config files? What are my packages am I installing? How do I partition my hard drives? What are my loading up, my scripts that I'm loading up, etc. And then when those machines come up, they get that configuration from the master server, and then they follow its instruction set, including custom scripts. You could write something by hand that says, I need it to edit this file and put these configs into it, etc. And then you could have, again, multiple configurations. The database servers would have a different configuration. You might have voice over IP that has a different configuration. So in my most recent stack, I had a development server, which was also the management server. It provided DNS and DHCP, which is IP assigning, and it handled this management system. And then I had 4 primary sort of stacks. I had voice over IP, I had web servers, I had databases, and I had text messaging. So those are my 4 different stacks. So I had around 40 servers in that cluster, and it was like 7 in each of those-ish, and then the 2 load balancers and configuration and a backup for the configuration. So that's sort of how you manage just huge number of machines, right? Every now and then you got to log into one, find out what the hell is going on. It's in a weird state. You got to figure it out. Sometimes you got to power it off. Most of the server level stuff, unlike your laptop or desktop, will have it has a bunch of different names, but eventually has a remote console mode where you can log into it even if it's powered off. You can turn it on, see how it's configured in the BIOS, see what it's going to boot to when it powers on, that kind of thing. So if you had a machine that was acting weird and was unresponsive, you could log into that lights out configuration and reboot the machine, even if it's completely offline. In addition to that, it's how we deal with bringing up a new node, right? So we talked about how do we upgrade these things. At some point, you buy new hardware. It might be faster. You might want to take something out of service. So you just take those new servers, add them to the configuration, put it in the rack, and it just brings itself up from scratch, and you don't have to do anything. Now, in a small cluster like 7 servers, you'll do it all by hand, and that's okay. It's not crazy to do that. They also have SSH command cloning. So like you run the command once, and it runs it remotely on each of your nodes. So if you just want to know like a log file, and I did this all the time, I want to just tail out the error log from the web server. So I would run that in the distributed shell, and it would give me the tail from all the web nodes all in one place. And so the leading indicator would be which the server name is, and then the error. So I could see, oh, somebody's on server 3 right now, and they keep having a problem logging in. So if a customer called in and said, I can't get logged in, I could see that log, and I go, is there something wrong with node 3? Does it not have their login information, or are they just putting in the wrong password? So you can see that. And then let's say they switched computers. They went to their tablet as an example. Now suddenly they appear on node 2 and they have the same problem. Well, it's a strong indicator it's probably at their end as opposed to being on your end.
So you're talking about physically installing multiple compute nodes.
Yep.
And
Yep.
When you're using Kubernetes and Docker to spin up multiple
Virtual. Yep.
virtualize multiple VMs basically in virtualized environments, how is that different than setting up like physical server racks in the data center?
Sure. You want to answer?
Okay.
Yeah.
So you're conceptualizing it wrong. Kubernetes itself is an orchestration layer that kind of sits on top of the virtual machines. So more or less, you're not creating machines in order to do that. What you're doing is you're creating pods. Those pods consist of multiple containers or a single container. It really depends. But you're more or less divvying out fractional resources from the underlying machines itself for that pod to run.
So look at it this way. We have these 3 machines, right? What he's talking about is adding a virtualized orchestrator, right, on these physical machines, and now turning these 3 machines into 30, right?
It's a lake of resources.
Exactly.
And you can have multiple fish swimming in the same part of the lake.
So now what happens is if this server goes down, this physical hardware dies, any of the pods that were physically running here just migrate over to these other 2 automatically and keep running if it's configured properly and you have shared storage. So there are some cases where they can't be migrated live, like if you don't have shared storage. Let's say you're just running a home lab at your house and you happen to have an old PC and you want to put it in the cluster. This guy goes down and then you just manually say, hey, migrate these over and then spin them up over here. No big deal. You don't need to have a super complicated setup. If you're in production and you're, Netflix, you don't want to do anything by hand. You want everything to happen automatically. And so we're just talking about the difference between the physical layer and the virtual layer. So when you're talking about Docker or the hell's the other one? Kubernetes. You're just talking about the virtual layer sitting on top of the hardware. And that's virtualizing the cluster, which is all AWS is doing. They have all these physical servers, and they take this little tiny piece of this one and give it to you. And if this hardware has a problem, your little piece just moves over there and runs on this one. They're just doing that times 1 million servers.
That's basically their revenue. Is that they're renting you a slice of compute at
Yep.
a premium,
Exactly.
right? They can afford economies of scale with massive numbers of compute resources, and then they can rent you.
So they're taking the one-time cost of this, which is probably the fastest CPUs made today, right? Platinum 8000s or AMD Threadrippers, like they're just the fastest CPUs they can. They're spending $20, $50, $100,000 on these machines, and they're just selling you a piece of that for $400 a month. That's all they're doing.
Till fries.
So the other piece of maintenance that's just really, really important, and this kind of goes to the question of how do we manage 100 servers, is documentation. No matter what you do, someone's going to come behind you. It might be yourself, and you cannot remember what the hell was I thinking when I did that, and why is there a machine sitting under someone's desk, and what's its IP? Write it down, write it down, write it down. That's huge advice no matter who you are, no matter what you're doing. Just remember documentation, documentation, documentation. It's so critical. I can't tell you how many times we've gone into something and gone, well, let's spend the next 3 hours figuring out what this was instead of 10 minutes reading the doc and knowing what it was and why it was there. So we've already talked about this a ton, but the question is, how do those technologies relate to the cloud? And the answer is, they're the same principles of taking physical hardware and selling it off little by little to everyone else in the world. That's all they're doing. So there is no cloud, it's just somebody else's computer, right? It's just somebody else's piece of hardware that you're running your virtualization on top of. Okay, questions? I know we've taken a bunch. Any more? What's up?
How is that different from like a NAS?
So a NAS, which stands for Network Attached Storage, is just the one piece we talked about. That database in the bottom, that's essentially a NAS. Only instead of database, it would be hard drive. So let's say you put a bunch of files on that, and you could have more than one physical piece of hardware, which is what we're talking about. And then that's just hard drive that's shared between any number of other machines over the network. Network speed becomes extremely important. So old-fashioned platter hard drive, right? You get something like 0.2 to 0.4 gigabits right, to access that. A new SSD will get you probably 0.6 gigabits, right? So if you just upgraded from spinning platter to SSD, your machine was suddenly twice as fast, literally. NVMe drives now, the newer ones, you can probably get 7 gigabits. So that's local to the machine. That's the PCI bus where it's physically plugged in. So now take that 7 gigabits and you want to put it on the network and you want 500 computers to share it. Suddenly your network speed matters a whole lot. So you're usually talking about 100 gigabit and fiber or InfraBand, something very, very fast, so that you're changing from one technology, which is the local bus, to the network to access that data. That's where the N in network attached storage comes from.
In the enterprise sense, you are correct, but she might be thinking from like the home sense. In the home sense, there is a lot different. I wouldn't run your anything, unless it's like just like your own personal website off of that. Because like it does have virtualization and all that stuff mixed into it too.
Right.
So like basically NAS has become this inflated home cloud.
So yeah, have you ever heard of TrueNAS or Unraid? Okay, so those are operating systems that can act as a network attached storage. And it's become very common on those to run virtualization right on them. You can run Docker and Kubernetes. I think you can run right on some of them.
I run Kubernetes.
Yeah. So basically what he's saying is you just got to be careful, because now if you're running a server on that device and it goes down, you'll lose the server and the storage that's paired with it. So personal stuff at home is totally fine, right? Because if you lose that hard drive, you're losing all your data anyway. If you've configured it properly, not permanently, just until you get it back up and running. But if it just goes off the network for some reason, maybe the switch it's plugged into died or the power went out. So in an enterprise situation, we'd be talking about no single point of failure. We'd have multiple servers, et cetera. But all NAS means is network attached storage. So just think of a hard drive that's on your network. That's all it is at the most basic level. Questions? More questions? Sure.
So I love war stories, and I know you've got to have some. So I know in the traditional sense of system administration, and even Cody here, he's got his fair share of driving at 3 a.m. to the data center. I'm curious, because let me start with my question first. How much in hosting costs, let's say per month or per year, whatever you choose, do you think it's wise to then start the discussion about moving to bare metal?
So this can be finicky in the sense that it depends on what level of provider, right? So there's a local place here in town that I was using when I first started out. It was like $900 a month, full rack, 20 amps of power, redundant, with a 1 gig network connection. So in that rack, I could run like 4 or 5 of those 4 node servers we were talking about, so like 20 machines, give or take. Now, for me, because I was doing the system administration at the time, some big provider had dumped a bunch of these machines. They were $500 for 4 nodes. They were just super cheap. It made all the sense in the world to just start there and not go to the cloud, besides that the cloud didn't exist at the time. But anyway, so the question becomes, if you're going to switch, which will charge you $4,000 for that same exact setup, your cost is different, right? Your calculation is different. I think the number one thing that is the biggest barrier to entry is the system administration labor. Either hiring somebody full-time or being able to outsource that to a consultant that you trust that can build the stack right and keep it running. So I have a war story for you on this specific event. I set up a cluster for somebody part-time. It's a friend of the family kind of thing. I set it up at no cost, got it all up and running. They were happy. They hired somebody who was a professor of cybersecurity somewhere in the country. I will not name any names. They were 2 racks down from my rack. So anytime I went to my rack, I always just peeked into their rack just for fun. One day I look in there and there is a Bitcoin miner inside the rack. I call the owner and I say, are you guys doing some kind of GPU high-level compute that you need a Bitcoin miner in your rack? And he says, no, what are you talking about? This guy that they hired put his Bitcoin miner inside their rack, attached to their power, attached to their network, started Bitcoin mining, Needless to say, he lost his device and all his Bitcoin that was on that device, and they called the police because it was theft of power and services. So what do you put into that calculation, right? Trust has got to be high on that list. Maybe this guy is great and knows everything there is to know, but if he's going to stick a Bitcoin miner and compromise your rack, it kind of doesn't matter how good he is. Or he might be terrible and might put a bunch of software in there like TeamViewer, and suddenly your machines are open to the world if someone figures out they're on TeamViewer. So it's hard to just say, like, straight up, here's when it makes sense to move to this. My normal philosophy on that is take the cost of the hardware and multiply it by 6. And if your cloud costs more than that, you should have an on-premise solution. So 6 months of the cost of the hardware usually overcomes the cost of cloud over time. You're going to have other costs like the labor to install it and the hosting and all that, but that's usually where that sort of balances for me. So if you just say, look, I'm spending $10,000 a month, that means if I'm spending $60,000 on the hardware, that's the time it makes sense to move. If you're spending $1,000 a month, you only got $6,000 to spend, you probably should stay in the cloud forever. Okay, I have one more slide. Somebody actually sent this to me today at 1 o'clock, and I just thought it was hilarious, so I decided to share it with the group. So this is over time. This is the planning stage, design, development, testing, and release to the public. So for those of you who are software developers, I thought you might appreciate that slide. Any more questions before we knock off? Okay, so I have one question for this group for the badge. Who can name one of the distributed network file systems I mentioned?
Seth?
Seth is correct. We have a winner.
There's probably docs online on how to hack that thing.
Oh, you went to B-Sides Portland?
Funny enough, I actually was speaking at a PHP conference in Portland, and one of the other guys, well, there was like nothing going on one of the days, and he's like, dude, B-Sides is happening at the same time as this conference. So and it was at the university, it was walking distance. So I walked in the rain of Portland.
Yeah.
And walked right in, and there was like $20. B-Sides is, by the way, if you're into cybersecurity or you're just dabbling, like B-Sides is super cheap, and is like the kind of like underground DEF CON-ish kind of thing. They have one here in Vegas too. So check it out. They usually have. What's that? They haven't put. Okay. Just if you do bsides.org, I believe is their website.
It'll be summer sometime.
Because they usually try to line it up with DEF CON, right? Like August-ish?
Yeah, it's the week before.
Week before? Okay, this guy knows. You look like you live at DEF CON. Heck yeah, no, okay, nailed
Yeah,
it.
it goes Black Hat and then DEF CON.
Cool. Any last questions here on by the way, that was an amazing talk.
Oh, thank you.
And I really appreciate it. I was already like churning in my head because I have a lot of stories where they were bare metal, then they went to cloud, and then now they completely regret doing that, and they're like, why did we do that? Or even vice versa.
Well, haven't called me.
Yeah, I know, right? Yeah. Yeah.
Taking all these principles of distributed systems and either cloud-native system design or bare metal design, where the principles are the same, it's just really your cost structure.
Yep.
That's one of the considerations, which is more cost-effective, but also, do you want full data sovereignty over all the data that exists in your database or your server, or would you rather trust a big cloud provider?
I agree. Trust is actually major. I actually have clients that will not put it in the cloud because they have contractual obligations not to share it with third parties, so they just can't use the cloud at all. So that can be a concern.
Yeah, it's just something to point out that, like he mentioned earlier, you are getting a section of a computer, so that means like the NICs and like the memory and all that, like yes, they're isolated, but hackers have found a way through various virtualization technologies to gather information from other VMs from a VM they have found.
So like if they're running on the same hardware, they can kind of sneak into the back door and see what else is running on that hardware. It could be tricky. It's not that simple, but that's the concept is that you have to have a level of trust because you're turning over your system administration to them. And if they just make a mistake and they have some vulnerability, you have no control over when they fix it or if they even notify you that there was a problem. I mean, there's many instances of break-ins happening and the company's not reporting them for months or years and then finding out your social security numbers on the dark net because they just didn't bother telling you. So, trust is a big thing for that. And depending on your data, especially if you're doing credit card transaction data or personally identifiable information, PII, it's very possible you just don't want to use the cloud on a trust alone.
Use somebody else. Lots of Fortune 500 companies use AWS, GCP, or
So
how would they architecting their systems so that it's software compliant, data encrypted in transit, data encrypted at rest, that they're, especially when you're talking about sensitive financial credit card information or whatever, how do they build using existing enterprise cloud providers to ensure software compliance?
So the real answer is you're not protected at the end. Just full stop, you are not protected. The law won't protect you. If something goes wrong and you try and sue them, you may not win. Their terms of use won't protect you, right? But you just mitigate as much as you can. Like you're talking about end-to-end encryption, encrypting at rest, encrypting in transit. That is true for your own stack as well. It's on the internet. What's to prevent a bad guy from finding some way through that you didn't know about and them stealing your data? So it's sort of it's sort of one of these things we all put our blinders on and pretend it's all perfectly safe and everything's 100% guaranteed. But the reality is you're just not protected. You have to take as many steps as you can to mitigate the risk. There's never a zero risk.
Okay, so what are some of those mitigation strategies?
Dedicated server.
Well, yeah,
dedicated
moving to your own
server.
hardware is massive because now you're not sharing your hardware with anyone else. So if there's a backdoor through the virtualization technology, you're not exposed to it anymore because it's no longer on their cloud, it's on your dedicated machine. But again, those techniques you're talking about, right? Encrypting the data and security audits, packet auditing, right? Auditing the network traffic to see hey, this is weird. We don't use anything on port 1850. Why is there traffic on that port? There's packet inspection. So at that load balancer level, you can actually look at each of the packets that are coming in and say, hey, that doesn't conform to our rules, notify a system administrator. You might add a block to that. We have a bunch of geographic blocking. So if our service is only available in the US and Canada, we might just say nowhere else in the world can reach that. For this high security company they worked for, they had a VPN, and the VPN was like that. We had a list of single IPs for their end users. And if you weren't on that list, you couldn't access the VPN, period. It just wasn't there. So you didn't have to worry about somebody scanning it, seeing your VPN port was open and trying to attack it because it just looked closed to them because they're not on the IP list. So again, it depends on where you're trying to protect, what techniques you're going to use. One of the biggest ones that actually solves some of your financial problems is outsource your credit card processing to someone else. Now, if there's a breach, they get sued, not you. And that's okay. Let it be their problem because there's nothing else critical there. You're not giving them social security numbers. You're not giving them user IDs. You're just giving them financial transactions, which they're responsible for anyway, right? Visa, MasterCard, American Express have all those transactions. Let them be responsible for it. When something goes wrong, let them get sued.
Okay, so that's more of a legal mitigation
Sure.
strategy than it is a technical.
But it's also technical at the
But
same time.
yeah, but in the end, right, like I said, there's just zero-day vulnerabilities, right? Somebody put out an operating system, there was a bug in it, you don't know it's there, some hacker finds it first and they leverage it. How could you be protected, right? There's only so much you can do. That's what I'm saying. It's sort of this fallacy that you can secure everything. There's always a level of vulnerability in anything that's on the internet, period.
Yeah. Just to add to that, I mean, there's various situations where you either want or have to move to dedicated servers, right? So like you said, like, can't you build it yes, you can build a secure environment in AWS. It can happen, right? AWS has GovCloud, CIA hosts stuff there, right? It's possible. But I guarantee you the real juicy stuff, CIA ain't putting on AWS, right? It's sitting on a server underneath somebody's desk.
So I don't know if anyone here knows, a long time ago there was a standard for the different levels of computer security. And I think it was the NSA that put it out. And the most secure computer, in their opinion, was a computer plugged into a UPS and not the electrical grid. The end. No other cords. Because in their opinion, even the power cord is vulnerable. So if it's plugged into the wall, there are power line technologies that you could go after to create a communication into that device. And that is a real thing. An uninterruptible power supply, a battery. So you plug it into a battery and not the wall so that they can't come through even the power cord.
It's like a clean
Yeah. So
energy.
that was like their strongest, most secure machine. No wireless technologies, no network technologies, just a computer plugged into a battery, the end. And by the way, that's not fully secure. They have found that you can attack machines with audio. You can attack them with radio waves, right? So machines that aren't even plugged into the network can still get networking through some of these other crazy technologies. I don't know if you know, does any of you have one of those heart monitors from Cardia? That's actually using audio to communicate with your device. It turns on the mic and it's listening to that thing, and that thing is transmitting audio. And that's how it's picking up your heartbeat.
That's crazy.
Yep.
Yeah.
The big one with audio is they're basically turning your mics into a keylogger where it's picking up the audio from
That's cool. Yeah.
It into, oh, they're typing this. They just type their password.
Yeah.
So to answer your question, is anything secure? Nope.
Well, that's why, like, Heartbleed, that happened, what, a couple years ago, maybe 3, 4, I don't know. But that was a situation where it was possible for somebody within a virtualized system to dump what was on the RAM, I believe, right? Yep. Via some sort of CPU x86 bug or something like that, if I vaguely remember. But bottom line, all these things are super, like, you need to be, like, high level, have teams, but there's hackers out there that have that kind of thing, right? So I worked at the largest payday company in the United States. They hosted on their own racks. They did not want all of those social security numbers out on whatever cloud, and they had 2 full-time system administrators. They were happy with paying Switch and just hosting it themselves, right?
And I mean, one of the biggest keys, right, is what's your real risk, right? If you're hosting social security numbers, it's much higher, right? If you're Netflix, do you care if somebody steals the movies? They're free anyway if you sign up for every month. So you're not really worried about somebody coming along and stealing your video library. A, it's too big, and B, it's accessible for a very low price anyway. Now, the credit card information, the user login information, that you want to secure. So again, it's what is your risk? I mean, it's a public website. You don't care about your images or the text on it. They can copy those anyway. So the level of what you're securing depends on the sensitivity of the data.
Are there hybrid approaches where you are still using a cloud provider for some things, but all the sensitive data is being stored on local server racks without internet?
Sure. I mean, one of the big things is AWS S3 has a really powerful sharing that if we're clients of each other, right, he can drop something in his S3 and I can access it for free, just instantaneously. They'll just route me to his S3 and I can dump it into my system. So he might say, hey, look, I'm going to give you my client file on S3. You download it and then delete it so that I just pull it down onto my local machine now. So it gave him an easy way to share it with me without me having to open any ports on my end. He didn't have to open anything new on his end. He's already using S3. I just download that sensitive data onto my local device and I delete it off the cloud. So yes, there are hybrid approaches for sure.
Okay, so that's more around secure data sharing.
Yeah.
I mean, designing a system. Okay, so let's say you're building a rack application, and the nature of the data is highly sensitive. It could be PII, it could be financial transactions, it could be legal documents. it's important enough that it's worth all the effort to secure. You want to harness an LLM such that its outputs are, if not completely deterministic, are somewhat predictable and can be verified by either a human or by another model. It has a custom system prompt that has a clear set of metrics for evaluating the response to model A, maybe a multi-agent RAG system. You need some way of characterizing or at least
So, okay, I totally got you. So what you want to do is virtualize your data and anonymize it first. So you take your sensitive social security number as an example, and then you MD5 hash it. Now that's not good enough, but let's just use that as the example. Now you can reverse that if you have a key, but you have that now in an encrypted, non-identifiable way. You're probably not going to use MD5 or just social security number by itself, but
Use MD5 twice.
you'd have to do something to it way better than MD5, but it doesn't matter. The point is you anonymize that data. You just give it some kind of identifier. Now you send out the non-sensitive information to the LLM because it has full access to the data. So if you send that sensitive information, that provider has all of that data. You have no idea what they're going to use it for, including training. You don't want them training on your private data. So you're going to want to anonymize your data first to protect yourself, then send the anonymized data, have them run against the non-sensitive data with some kind of an identifier in it, and then send you back the results that you can then compare the identifiers.
So you're using a hash algorithm. You're using some protocol to first anonymize the data, then you're providing the key to an LLM to decrypt that data, do its processing.
Not even decrypt it. You're
No.
just giving it a reference like, I
Right.
have person X. They don't know that it's John Doe.
Let's just say you number them numerically, 1 through 100, right? So instead of sending their social security number, you just send ID number 1. You send the rest of the non-sensitive data. It runs the model and says, okay, your order is now 345. Your local system ran. It also said 345. You know it's good. So now you have no risk because you didn't send the sensitive data. You just sent an identifier. That's the easy way of doing it.
Think of it as a lookup table of sorts.
Yeah, exactly.
It almost sounds like you're using a SQL database.
I mean,
Yeah,
that's an example. Yes, you could be. But the point is simply, if you give the sensitive data, no matter what you do to it, to the LLM, there is a chance they can break that and find out what that sensitive data is.
So that's a pretty good use case for self-hosting.
Yep.
Using your own hardware.
Exactly.
You can self-host openly models.
Yep.
Depending on the hardware you have, quantized, whatever.
Yeah.
233 or something. And then if you're the one hosting the model, then you have data sovereignty. You're not sending that data off to the cloud to be processed by one of the AI.
Exactly right. Absolutely. Okay. You
Yeah.
want to give away some JetBrains?
Yeah, so we have a bunch of licenses. Who here would be interested in a JetBrains license? One. JetBrains license? It's a IDE. Yeah. Okay. So
license work with their AI thing?
I think it comes with 1 year. I'm not totally sure. I think there's a trial for their AI, the Junie plugin. But yeah, so cool. I'll get your email here at the end, and I'll shoot you over the free license here. Again, thanks to Corporate Coworking. Again, if you want a free day pass, feel free to scan one of these QR codes. I do have something kind of important to say. So, I don't know how to word this. So for the last almost 13 years now, I've been hosting this meetup once a month. I poured my heart and soul into this thing. When I was attending ITT Tech back in the day, because I was applying for jobs and nobody would call me back, I had no experience. But I went to ITT and I started applying for jobs, and I was getting calls back because they saw I was going to college for it, and I got my first programming job. I was making dirt, whatever. I started jumping on the internet trying to find other people I could kind of talk to and learn from. I worked in a very small team. In fact, probably my first 3 or 4 jobs, I was either solo or there was like one person I was working with. I was dying for something like the meetup. that we have today, right? Which is why when I had the opportunity to take over Las Vegas developers, when Mike Zithlow left and when Adam Englander was too busy to host the meetup, I jumped on the opportunity over 12 years ago, and I've kept it running every single month with the help of some amazing co-organizers. Thank you, Rob. Thank you, Cody. I mean, I'm just thinking about the good old days when Switch actually had a freaking co-working place, and we used to, it started with like 4 of us in a meeting room, like, let's talk about Laravel or whatever. And it was just a good time. And then it evolved. I mean, some of our meetups hit probably 60 people. It was crazy, right? Like when we were in the big room there. The economy's changed a lot. Times have changed a lot. And even the local community here in Las Vegas for software development has expanded, right? There's Sin City programmers. There's Adam Englander running the Python meetup, which is, by the way, a great meetup. He's a great person. There's what's the thing downtown? Tech Alley. Tech Alley's a great place. Bottom line here, guys. Over the last couple of years, I've gone into a weird world of content creation. Some of you know exactly what I've been getting into, but what started as a hobby has now been a full, complete consumption of like my life, along with my kids and my family and everything else. And I've done a pretty poor job about updating the meetup, about organizing this thing, and I simply just don't have the time. At the end of the year, I think I'm done. And it pains me, but I wanted to keep it going. So hopefully within the next 6 months or something, we can have some people stand up, raise their hand, and take it over. If not, we'll let the flame die out. There's other communities out there that can probably fill that gap. That's it. So that's what's going on. I've been super busy. I've been super overwhelmed. And by no means, if this did continue, I'd still pop in and things like that. But to keep this going every single month, it takes time. And I'm just not being able to, I mean, luckily these guys are basically the ones that are kind of patching me together. You were asking me, how come you haven't updated? I'm like, I literally told them update it. And it's just a nightmare. Like I'm doing a pretty bad job about keeping this thing going, and I realize that. And I either have to make the choice of letting it go or trying to lean into this more. But yeah, that's what's going on. So thank you again. We've had a hell of a run. Regardless, I'm not leaving tomorrow. But you know, I do plan on either taking a back seat here at the end of the year, or if it dies, then you know, I'll go down with the ship, I guess. But
how about 13 years, right?
Yeah.
Come on, people.
When I was in college, I was dying for something like this, and we've had some great people who, you know, came through, and I met a lot of great friends, and this is a great place to network, right? The whole reason I started this is so all of us can learn. It's a free environment. I've seen paid events and stuff, and that always left a bad taste in my mouth, which is why I've always made this a completely free event. I make $0 off of it. I buy the pizza every freaking month. I ask nothing of anybody other than just to show up, have fun, ask questions. Every now and then, throw your hand up for, hey, I want to do a talk. Thanks, Chad, right? This is what it's all about. So if it's not a meetup of one, I'd be talking into a brick wall. It's a team sport, right? Hey, yeah, team sport, yeah. So thanks, guys. Yeah, sorry to get a little heartfelt, but that's what's going on in my life. I just got a lot going on, and I got to switch gears a little bit. So, but thank you. Without you guys, I wouldn't be here today. You know, so. All righty, and yeah, I think it's PT's o'clock.